In the SCE Fluids Lab, Dr. Jerry Richardson and graduate student Jonathan Daldalian have contracted with Water Resources Solutions to assist in the building of a Woodson County Fishing Lake spillway model. In 2016, severe rainfall failed the spillway of this reservoir. Dr. Richardson and Jonathan were able to model the spillway failure and propose and test a redesigned spillway using physical modeling combined with 3D CFD modeling.
The solution to the Woodson spillway dam that we came up with was to design what we call a baffled apron to control the energy out the flow as it comes from this high elevation to the low elevation. You'll see how well it shreds the flow and knocks the energy out. What we want to do is get to the point where the velocities are not too high down here, so they don't erode out the channel and cause additional problems downstream. And then you can see how the baffled apron creates turbulence. And that turbulence is a way of reducing the amount of internal energy in the system. And so then it comes on down, and by the time we get to the bottom here, the water is relatively flat and smooth again before it goes down into the river channel. Really is not very modelable using a numerical model or a computer model. What we do is we usually use the physical model to then calibrate a numerical model to get the numbers that we need to do kind of final design analysis. So this is only a piece of it. We're doing a physical model combined with what we call a computer model. And many hydraulic engineers just do the computer model, but they don't have anything to correlate to, and that's why we want to use, we've been using both of these, and by doing both of these, we've been able to actually save clients an enormous amount of money.
It's in the permitting phase right now. They're hoping to have it built by April, so it's a really accelerated schedule on it, which was fun. I built this thing in 21 days. I think the failure was 23 days after, so it was pretty crazy construction schedule.
They want to get this in before the next flood season, the next big rainfall season.
Yeah.
Because if the river, right now, if the river, we would get a big rain and the reservoir fills up, it's going to come running back down here, and it could erode all the way back in, and we could have additional problems with the reservoir.
Yeah, they're actually draining the reservoir currently. So when we were down there doing the site investigation, they had a pump that was taking all the water out in case it rained, so the reservoir could fill up and it wouldn't actually engage the spillway. So, but yeah, they're taking measures, but they want to make sure before the next rainy season this all gets filled.
This is actually called a pitot tube, and it's the same thing we see on the front of airplanes. Okay, and so as the water stagnates on the front of here, it rises up in the tube. You may not be able to see it too well, but it rises up in the tube. We'll put a little dye in there. We're not so worried about the actual velocities in the model, because once we get this done, we take this into a numerical model, and the numerical model gives us a much better understanding of the velocity.
The water's going much higher at different locations, which the velocity is higher. You get a good one. There it is. If you go down here, you see
very little velocity.
Much lower velocity.
And that's what we're looking for. Very low.
You can't hardly
very
see
low
it.
velocity. They're very uniform.
Here you can see there's a much higher velocity. And then that's all we do. We just take velocities in different locations and the depth.
So this is really mostly about flow patterns, looking at the secondary flow patterns that are in here. You got a little more, kind of just a bottle design. So we really want the flow patterns to be fairly uniform. So we'll look at with dye, look at the dispersion of things like dye. And so you can see right here, there's a little area of flow that's not really being very effective because the dye is staying here. Okay, I poured that in quite a while ago. The dye is not leaving. So really this area is not really very effective at moving the water downstream. So these are areas that, you know, we might be able to adjust the geometry of the model to improve that. Where that's happening, it's not really a big deal for us. But in other places, sometimes it can be really important. We can adjust the model very quickly while we're running it. If we try to do that in a numerical model, it's not going to happen very quickly. It's very hard to do. So we can get everything the way we want it, and then we go back and just verify all the numbers of the numerical model. So we use the two together.